Ladies and gentlemen, dear viewers, dear listeners, dear students, you're welcome to today's lesson on global distribution of temperature. Today we shall be looking at how temperature is distributed over the Earth's surface from the equator to the poles and from the Earth's surface into the atmosphere. During our last lesson, we were looking at heat transfer over the Earth's surface. But today we shall be talking about global distribution of temperature, and that is lesson 6 under meteorology, climatology and hydrology. As far as the lesson objectives are concerned, we are expected to be able to define temperature and explain how temperature is different from heat. We are equally expected to describe the spatial temperature pattern of the Earth's surface, and we shall be equally expected to be able to explain the factors that are responsible for the spatial variation in temperature. And lastly, by the end of this lesson, you are expected to be able to discuss the role of astronomical factors in the horizontal distribution of temperature. Now, what is temperature? What is heat? Temperature is a measure of the average kinetic energy of the particles in a substance, and temperature is measured in degrees Celsius. It can be measured in degrees Fahrenheit, and it can equally be measured in Kelvin. So these are the three different measures of temperature. Either you express it as degrees Celsius, degree Fahrenheit, or you express it in Kelvin. On the other hand, heat is a transfer of thermal energy between objects at different temperatures. We saw this definition during our last class where we were talking about heat transferred. And heat, of course, can be transferred through conduction, through convection, through radiation, and the latent heat of vaporization. Heat, remember, can also be transferred through radiation. Temperature and heat are different in that temperature is a measure of the average kinetic energy of the particles in a substance or in a body, while heat is the transfer of thermal energy between objects or between bodies. Let's move on. We shall be talking now about the spatial distribution of temperature over the Earth's surface. And under that, we shall start by looking at the horizontal or latitudinal distribution of temperature. It should be noted here that temperatures are not evenly distributed over the Earth's surface. The general tendency we have is that the equatorial regions are hotter than the temperate regions and the polar regions, while the polar regions are colder or are the coldest, while the equatorial regions are hotter. Now, this is because, one, the sunlight is received directly over the equatorial regions. When we look at the shape of the Earth's surface, remember, the Earth is spherical but bulges at the equator, which means that the equator is even closer to the sun than the poles are. Secondly, because of the bulge nature of the equator tends to have a shorter atmospheric distance that the sun rays have to travel through in order to reach the Earth's surface, while as far as the polar regions are concerned, there is a wider atmospheric distance that the sun rays have to travel through before reaching the Earth's surface. Okay, now away from that general view, let's look at the factors that are responsible for the horizontal variation in temperatures. And under that, we shall start by looking at the astronomical factors. Under astronomical factors, we have one, the influence of latitude and the shape of the Earth. Firstly, we are saying, or we would see that the latitude of a place is its distance from the equator. As mentioned above, the equator receives more direct sunlight than the poles. So places closer to the equator are generally warmer than places which are closer to the poles. Yes, we say the equator receives more of direct sunlight because the sun is always overhead at the or over the equator. That we saw even back there in Form 3, we discovered that the sun is always overhead at the equator but reaches the temperate and the polar latitudes obliquely. This is why the the equatorial regions or the tropics are generally hotter than the temperate and polar regions. Secondly, the Earth's surface is also curved, which means that sunlight is more concentrated at the equator and less concentrated at the poles. This is because the sun has to travel through more atmospheric distance to reach the poles. Yes, that we have mentioned when we were looking at the general tendency. On this slide, we have two pictures. The first one explains the fact that the sun is always overhead at the equator and the tropical regions, and this explains why we have the red band from west to east covering the equatorial and tropical regions of the world. This is to tell you that places which are found over such regions are generally hotter than places which are found away from these regions. Now if you look at the polar regions which are found at the extremes, you will notice that they are painted white, which means they receive little or no sunlight compared to the equatorial and tropical regions of the world. Now moving over to the second picture, we have the Earth and the Earth's atmosphere, which is the envelope of air or gases that surround the Earth's surface. Now this one indicates the distance which the sun rays has to travel through the atmosphere before reaching the Earth's surface. Now if we look at the equator, which I will label here 1, we see that there is a shorter atmospheric distance for the sun to cover through the atmosphere before it reaches the Earth's surface. Meanwhile, if we come to the polar areas, that I will label 2, we see that from here to here, the distance is much wider, which the sun ray has to travel through in the atmosphere before reaching the Earth's surface. Because of this variation in distances, the shorter distance, of course, will mean that more heat travels through and reaches the Earth's surface, making the Earth's surface around the equatorial regions to be hotter. Meanwhile, because the sun ray has to cover a longer distance over the poles, it reaches the Earth's surface when it is already weak, when it has given out much of its heat and there is little or nothing left to heat the Earth considerably. That is why the equatorial regions of the world are hotter than the polar regions of the world. Okay, away from that, let's look at the revolution of the Earth and its impact on the temperature distribution of the world. This is the second astronomical factor that has a great role to play as far as temperature distribution over the world is concerned. The Earth's revolution around the sun also influences temperature. During the summer months, the hemisphere that is tilted towards the sun receives more direct sunlight than the hemisphere that is tilted away from the sun. This is why the summer months are warmer than the winter months in the northern hemisphere and vice versa in the southern hemisphere. This can be explained better using this diagram, which we shall elaborate on in the following slide. Okay, dear students, here we have the image representing the movement of the Earth around the Sun on its orbit. That's a revolution. And how does this movement influence temperature distribution over the Earth? Now, let's begin with September. During the September month, here we go, we notice that the Sun is overhead at the equator. This is why almost the whole Earth, in fact the face of the Earth that is in direct contact with the Sun, receives a lot of sunlight. However, it is since the Sun is overhead at the equator tends to receive more heat than the polar regions. The equator is this band here, and so the equatorial regions during the September period tends to be more heated than the polar regions. Now, if we move over to the December period here, during this period, the southern hemisphere is more exposed to the Sun. This is when the Sun is overhead at the Tropic of Capricorn. Because of this, the southern hemisphere is more exposed to the Sun, and so it is the southern hemisphere that tends to be heated more than the northern hemisphere, thereby making the southern hemisphere during the December period to be hotter than the northern hemisphere. If we come to the opposite position, which is in June, we notice that the northern hemisphere is rather tilted towards the Sun. This is when the Sun is overhead at the Tropic of Cancer in the northern hemisphere. Because of this, the northern hemisphere in June is more heated and warmer than the southern hemisphere, which is tilted away from the Sun. Now, what obtains in September is not different from what obtains in March, because during the March period as well, the Sun is overhead at the equatorial region. Because of this, we tend to have equal length of day and equal length of night, and the equatorial regions at this period of the year are hotter. Of course, they have always been hotter, but during this time the Sun is overhead at the equator than when it is in June or December. Okay, we move over to the next slide. Notice that we have come to the end of today's lesson, whereby we have looked at heat, we have defined what temperatures are, we have looked at the difference between heat and temperature, we have looked at the horizontal distribution of heat over the Earth's surface and the factors that are responsible for this horizontal variation. Under that, we have looked at two major factors that fall under astronomical factors, and this had to do with the revolution of the Earth and the shape of the Earth, and how these two factors affect the horizontal distribution of temperatures over the Earth. In our next lesson, we shall go ahead to look at other factors that are responsible for the variation in temperatures over the face of the Earth. And until then, make sure you go through the lesson very well, revise, and see you during our next class. Until then, I say ciao.